Welcome to Math edition of Science E-Learning Academy. Today we shall be looking at set theory. Set theory is actually a branch of mathematical logic that deals with sets and its properties. But the question is, what is set? A set is a well-defined collection of objects or people. Sets can be related to many real-life examples, like a number of students in a class. A family is a set of number of people, and which comprises a father, mother, and children. So it can as well be a number of matchsticks in a matchbox. So the representation of this set can be done in two ways. Set representation. Can be done in two ways. The first one is roster or tabular form, and the second one is the builder form, set builder form. In tabular or roster form, the elements are listed and separated by commas, and it is enclosed with a curly braces. So for example, if I have a set of number like 1, 2, and 3, this is what we mean by roster representation. All the elements, what we mean by elements is the number in the set. That is, number 1 here is an element, same with 2 and 3, they are all elements. So we have 3 elements in this set. So after listing the bracket, the numbers, then you enclose it with a curly bracket. So for a builder form, basically here the elements, they have a unique properties, like they have a common properties. Take for instance, if I say that n is equal to even numbers less than 10, even numbers less than 10, so even numbers less than 10. So I have n now. I can represent my n in this form. Let's say x, and x is even number less than 10, and close it with a curly bracket as well. So this is what we mean by a builder form, builder representation. Types of sets. There are different types of sets. The first one we shall consider is finite set. A finite set is a set having a finite or a countable number of elements. In other words, it is known as a countable set. For example, if I have p, now if p is equal to even number less than 30, that is 2, 4, 6, less than 30, that is 28, less than 30, then the elements are easily counted. So this example of a finite set. Then number 2 is infinite set. Infinite set is a set whose elements cannot be counted. For example, if the same p now we say is even numbers, a set of even numbers. This set of even number, okay, let's say set of even number. These even numbers can range from minus infinity to positive infinity, so it is not countable. Then the number 3 is empty set. Empty or null set. From the word empty, we already know what the meaning is. An empty set is a set that has no element. A set that has no element. So this can be represented as, represent it as this or this. The next one is equal set. Two sets is said to be equal sets when they have the same element. For example, if A is equal to minus 1, 2, 3, 5, and B now is equal to 5, 3, minus 1 and 2. Looking at this, they have the same elements but in different arrangements. So both A and B are said to be equal sets. Then the next one is equivalent set. Two sets are said to be equivalent if they have the same number of elements. Take for instance, A now is equal to, if I have A to be 1, 2, 3, and 4, and B is equal to A, B, C, D. So if you have A, the number of the elements in A are 4, then the elements in B are 4 too. So we can say that A and B are equivalent subsets. If I have A to be a set of number 1, 2, 3, 4, 5, and B now to be as well a set of number 1, 2, 3. It's clear that A contains all the elements in B. Then we can say that B is a subset of A. B is a subset of A, and A is a superset. Superset of B. Superset in the sense that it is housing all the elements in B. So the next one we shall consider is a power set. Assuming A is a set of number, then we can define a power set as a set of all subsets of A, including the set of itself and a null set. It's usually denoted as P. And the formula is 2 raised to power n, where this n now is the number of elements. For instance, if A now is equal to 1, 2, 3, then from this set, the n is equal to 3. Therefore, our power set is equal to 2 raised to power 3, and 2 raised to power 3 is 8. This means that both the subset and the empty set must be equal to 8. Then we have that our empty set, then subset 1, 2, have 3, then 1, 2, 1, and 3, 2 and 3, and the set itself. So counting this, you have that 1, 2, 3, 4, 5, 6, 7, 8, which is equivalent to what we have as power set. The last one we shall consider is universal set. Any set that contains all the sets under consideration is known as universal set. So, for instance, I have A to be 1, 5, 6, 8, and 10, B to be 2, 5, 7, and 10. Universal sets will be a set that contains all the elements in A and all the elements in B as well. Set representation. There are different symbols used in a set representation or set notation. Just like we defined before, when you have a collection of objects, number closed with this curly bracket, then we said it's a set. For A union B is represented like the same thing. It's A intersection B. A intersection B is what does A and B have in common? That's the intersection. You represent it as this: a subset, superset, power set, and empty set. They are all represented in this way. The next thing we shall be looking at is set operation. The set operation are performed in two or more sets to obtain a combination of elements. We have different forms of set operation. The first one is the union. Union of sets. If I have A to be a set of 1, 2, 5, 8, and B to be a set of 1, 3, 5, 7. So A union B will be equal to writing the element in A and B without repeating anyone. Like 1 and 5 appeared here in A and it appeared in B as well. So we are going to write everything here without repeating any number. So I have 1, let me write it serially, 2, 3, 5, 7, and 8. So this is the union of the two sets A and B. The second one is intersection. Intersection of set. So considering this A and B as well, what intersection means is the connection between A and B. That is, what elements do A and B have in common? So if I have to represent it now as A intersection B will be equal to what they have in common. 1 is there and 5 is there. So 1 and 5 is A intersection. The complement of a set. If I have a universal set U to be 1, 3, 6, 7, 8, and 10, and A to be 3, 6, 8. Therefore, the complement of A is a set of all members of the universal set U which are not the element of A. This means that A complement or A prime is equal to element in the universal set that is not in A. Therefore, we have 1 is a universal set and it's not in the A. Okay, let's cancel out. We have 3 this place, we have 6, and we have 8. That means that A complement will be 1, 7, and 10. The last set operation is the difference of set. Differences of set. If I have a set of number A, 3, 5, 8, 9, 12, and 2, and B to be a set of these elements 2, 1, 5, 9, and 12. Therefore, the differences of two sets A and B is set of elements which are present in A but not in B. For instance, if we are asked to find the differences of A and B now, have A minus and and B minus A. For A minus B, we have that starting from the first element in A, we have 3, B doesn't have 3, then we'll write it down. Then 5, B has 5, B doesn't have 8, write it down as well. B doesn't have, B has 9, it has 12 and 2 as well. So our A minus B is this. For B minus A, let's as well start from the first element 2 here. A 2 is not in A. Okay, 2 is in A, so 1 is not in A, write 1. 5 is in A, 9 is in A, 12 is in A, so the set now is 1. This is how to calculate the differences of sets. The next thing we shall look at is set theory formula. This formula will be very good while solving Venn diagram. So if I have a set A and B that intersect with each other, then the formula would be number of A union B is equal to the number of A plus the number of B minus the number of A intersection B. But if the two sets do not intersect with each other, that's disjunct sets, I have that the number of A union B is equal to the number of A plus the number of B. So, but if it's 3 sets now that intersect with each other, you have that the number of A union B union B union C is equal to the number of A plus the number of B plus the number of C minus the number of A intersection B minus the number of A intersection C minus the number of B intersection C plus the number of A intersection B intersection C. Just take note of these formulas. We'll be using it to solve Venn diagram without drawing the diagram. We'll just input our parameters in this formula and compute it and get our final answer. Let's solve problem pertaining sets. The first question is, given that the universal set is even numbers between 0 and 30, and P the multiple of 6, if P is set of multiple of 6 between 0 and 30 and Q is a set of number that multiple of 4 between 0 and 30 as well, okay, have our universal set U to be a set of even number between 0 and 30. Even number 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, and 28. Even numbers are number divisible by 2. Then the next one, P multiple of 6, that's number divisible by 6. That's between 0 and 30. We have 6 and 12 18, 24, between 0 and 30, then we have the Q is multiple of 4. Number divisible by 4, 4, 8, 12, 16, 20, 24, 28. And so the question asks, we are asked to find P union Q complement. Before we find P union Q complement, let's find P union Q. P union Q will be 4, 6. That's writing the element of P and that of Q without repeating any number. We have 4, 6, 8, 12, 16, 18, 20, 24, and 28. This is P union Q. Therefore, P union Q complement will be the numbers in universal set that is not element of P union Q. So let's move serially. 2. We have 2 here and there's no 2. So write it down. 4 is in P union Q. We have 6 as well. 8. Okay, let me cancel. 4 is here. 6. We have 8 in union set. 10 is not there. 12. 14 as well, not there, not here. 16 is, you have 18, 20, 22, no, 22, 22, so 24, 24 is here. 26 is not, alright, 26, then 28. The element of P union Q complement is 2, 10, 4, 22, and 26. Going back to our option, we can see that option A is our answer. Our second question says that if X, Y, and Z are subset of the universal set Y 0 less than or equal to Y less than or equal to 6, find X intersection Y union Z complement. First of all, let's break down the universal set. We have that our universal set U is equal to Y 0 less than or equal to Y less than or equal to 6. This means that, let's break down this part. We have that 0 is less than or equal to Y, and same Y is less than or equal to 6. So if 0 is less than or equal to Y, that means Y is greater than or equal to 0. And same Y is less than or equal to 6. For us to write our universal set now, it shows that the element of this universal set will be greater than or equal to 0, and at the same time less than or equal to 6. So we have that 0 now, 1, 2, 3, 4, 5, and 6. This is our universal set. But the question asks us to find Y union Z complement, X intersection Y union Z complement. Let's take it bit by bit. Let's find Y union Z. Y union Z. Y union Z is write down the element in Y and Z without repeating any one. So I have 1, 2, 3, 4. This is Y union Z. Then Y union Z complement will be equal to writing down the element in universal set that Y union Z does not contain. Let's cancel the elements of Y union Z in the universal set. So 1, cancel this 1, cancel 2, 2 appeared, 3 appeared as well, and 4 appeared. So Y union Z complement will be 0, 5, and 6. Our X is equal to 0, 2, 4, and 6. Therefore, X intersection Y union Z complement will be equal to what this and this have in common. There is 0 here, there is 0 here, write down 0, and there is 6 here and 6 here. Our final answer is 0 and 6. Checking the option, we can say that option C is the right answer. Thank you for watching our video. If you have any question, feel free to email us at science-elearning-academy@gmail.com. Science-elearning-academy, one word, @gmail.com. Please subscribe to our YouTube channel and follow our social media page, Facebook, TikTok, and Instagram, Science E-Learning Academy. Thank you.